Okay, so after the lab simulation class, you should have kind of noticed that there's a relationship between your starting momentum and your ending momentum when there are collisions. And that comes from the law of conservation of momentum, which essentially means that the amount of momentum that we have in a total value cannot change. Okay? So you'll most often see that written this way. Your however many objects you have on one side of the equation will be written as like MAVA or MBVB, or if there's three things, there might be MCVC, all right? And it's going to be set equal to this, pretty much the same thing, but they have these little prime numbers, which means after. Okay, so what this is essentially saying is that the momentum of our two objects before the collision is equal to their momentum afterwards. So total momentum does not change. However, the momentum of the individual objects can, because their velocities will change. Okay? So the kind of textbook definition of this is that the total momentum of an isolated system, meaning there's nothing like extra coming in there or leaving, is constant. So the previous slide, you saw two objects bouncing off of each other. You can also have collisions where two things hit and then stick together and move together. Okay? Same equation helps here. It's just now, instead of being at the end VA prime and VB prime, we have just V prime because they move together with the same velocity. Okay? A third example of momentum conservation is, this would probably, like, you'll see this as far as like a throwing problem or an explosion problem, where we start with a momentum of 0 and then the objects separate in some way, but they're going to go in opposite directions. All right, so their total momentum is still going to end up being 0, because the thing that's going backwards will have a negative momentum and the thing that's going forward will have a positive momentum, and those momentums will equal each other. Okay, so just to take you through a couple samples. So here's an example of things that bounce off of each other. We have two billiard balls of mass 1.2 kilograms collide head-on. The first ball is going at 2 meters per second in the positive direction, and the second is going 3 meters per second in the opposite direction. After the collision, the first ball is going at 3 meters per second in the negative direction. What is the velocity of the second billiard after the collision? So these problems become really important to pay attention to your directions. It's also really important to note the before and after situation. All right, I usually, with these, is very easy to sit there, and if you're unorganized about setting up these problems, to make a silly mistake and plug in a number in the wrong spot. So I usually take a little bit more time with these, setting things up, and on, say, quizzes and tests, if you do this and set it up correctly and then make a stupid mistake somewhere else, this is going to be entirely minimize the amount of points you lose. But I usually set up a before and after chart so that I don't lose any numbers and I don't put anything where it doesn't belong. Prime A, MB, and V prime B. All right, and all of these problems, or most likely all of these problems, we're just going to do with velocity changes, which is why we make the velocities the primes. But technically, if you had a mass change here, but then we're getting into a non-isolated system. So the isolated systems, the mass stays the same. So we have 1.2 kilograms as all of our masses in this case. It's possible to have different ones. And the mass before and after will always stay the same for the individual objects. And then the first ball is going 2 meters per second in the positive direction. So we'll make that positive 2. And then the second is going 3 meters per second in the opposite direction. So that should indicate to you that we need to make that a negative number. After the collision, the first ball is going 3 meters per second in the negative direction. So now that becomes a negative 3. And the second billiard ball's velocity is our question mark. So once I have this organized, it's really easy. I just plug it in where it goes. So I'll have 1.2 times 2 plus 1.2 times negative 3 equals 1.2 times negative 3 plus 1.2 v prime b. And from here, you just simplify, move things over until you get down to what VB is. So you'll have 2.4 plus negative 3.6 equals negative 3.6 plus 1.2 VB. This is going to become negative 1.2 equals negative 3.6 plus 1.2 VB. Then that simplifies even more to 2.4 equals 1.2 VB. And then if we divide both sides by 1.2, you get that VB is equal to positive 2.0 meters per second. Okay, so these problems are not very complicated, except for the fact that you have to be organized about it. If you switch one number, it completely affects your final answer. Okay? So one more example, we have a football player with a mass of 90 kilograms going north at 2 meters per second and collides with another player with a mass of 100 kilograms moving south at 3 meters per second. If they stick together after the collision, what velocity and direction will they move? So again, I set up the before and after situation. Now, one thing that's a little different about this is because they stick together, really, these two final velocities aren't different from each other, so we don't need the letters anymore because they're going to move together, so they will have to have the same velocity. So we're going to have separate MAs, MBs, and VAs and VBs for the before, but after, you'll have your two masses, but your velocities no longer have distinguishing letters. They are the same velocity. So that way it doesn't, if you write it that way, it doesn't end up feeling like you have two unknowns to solve for. Really, we only have one, because they're going to be moving at the exact same velocity. So 90 kilogram guy is going to be A, and the 100 kilogram guy is going to be B. And then VA was moving north at 2 meters per second. If you remember our discussion at the beginning of the year, north is considered a positive direction, so plus 2 meters per second. And then the other one is moving south, that's the opposite direction, so that's going to be negative 3 meters per second. And then our questions is the V prime. What is their velocity afterwards when they stick together? So we're going to plug them in. We'll have 90 times 2 plus 100 times negative 3 equals 90 V prime plus 100 V prime. If you simplify, you'll have 180 minus 300 equals 190 V prime. And then this becomes negative 120 equals 190 V prime. And V prime is going to be equal to negative 0.63 meters per second. Since we get a negative number, that indicates that their direction has to match the negative sign. So this is going south. Okay? So make sure you fill out the online form, and I will see you in class.